Our next lesson in geometry is geometry undefined terms, lines. But let's review a little bit. A point has what? Okay, a point has no shape, no color, no size, no physical characteristics because it is imaginary. Okay? The number of points that would fit on a period at the end of this sentence can be counted. True or false? It's false. You can't count them because you can't see them. What does a point represent? Okay, a point represents location. What physical properties does a point have? It doesn't have any physical properties. How do you represent a point? With a dot. Okay, points are usually labeled as capital letters. Is a point imaginary or real? Imaginary. The three undefined terms in geometry are point, line, and plane. True or false? True. Okay, I want you to go through that. If there's any of that you didn't know, I want you to stop the tape, go back and do it again, and make sure you know it before you do the next lesson. Go ahead and skip a space. Put today's date. Okay, today we're going to talk about geometry, undefined terms. We're going to talk about a line. Our goal for this lesson is to list properties and characteristics of the undefined term line. In the last lesson, we noted that David Hilbert made certain revisions to Euclid's geometry. These changes became known as Hilbert's axioms. Some of Hilbert's abstract concepts can be reduced to a simple form. They are the building blocks on which our geometry will be built. And like we said, they are point, line, and plane. And today we're going to talk about the line. Einstein once said about scientific theories, everything should be made as simple as possible, but not simpler. Einstein's words remind us to apply the principle of Occam's razor in evaluating theory. Okay, so the first thing we need to do with a line is draw a picture. Okay, let's draw a picture of a line. Here we go. This is a line. In order for it to be a line, you have to have arrows on each end. Okay, otherwise it's not a line, because the arrows represent that it keeps going forever that way, and it keeps going forever that way. Okay, now let's name the line. And how you do that is we have to put 2 points on the line. Okay? So I don't care where you put the points. I'm going to put a point here and a point there. And you can label them whatever you want. I'm going to label mine A and B. So to read this line, I say A, B, and I put a line over it. Then I know that I'm talking about line A, B. Okay? This is called line A, B. That's how you read this. We can also agree to name a line by using a single lowercase letter. We can say or read it line AB, or we can label a line a different way. I can put a line here. And instead of labeling any points, I can just say, okay, this is line H. Okay? And so that's what I would say. I would say line H. Okay? We'll explain a line this way. A line can be thought of as several set of points lined up one after another, extending infinitely in opposite directions. We will think of the line as being straight and not curved. Okay, so we're only talking about straight lines right now. A line has no width, no thickness, only length. Since it is a set of points, it cannot be seen, so it is also imaginary. In the real world, a line can be represented by a pencil, a meter stick, a straw, or an arrow. Notice that these infinites are not infinite in length, a phenomenon we observe when we try to explain abstract ideas with real-world things. Okay, so remember, think of a line as a set of dots. Okay, just a bunch of dots that connect and they go on forever. That's a line. Alright? Because each dot represents a different number. This dot may be 1/2, that dot might be 5/17, that might be, you know, every fraction there. And there's 1, and there's 1 and 3/10, 1 and 4/10, 1 and 5/8. Okay? Each dot represents a different number, and it just goes on and on forever. The relationships we've observed are what Hilbert classified as an undefined relationship of incidence, meaning lying on, being in, or being between. In the not too distant future, we will become familiar with Hilbert's postulates of incidence. And we didn't put that in our notes last time. Since it repeated it, maybe it's important, maybe it should be on here. So, Hilbert's undefined relationships of incidence. And that means lying on, being in, or being between. Alright, I want you to study this lesson and go ahead and answer the questions.